Okay, so today we're going to talk about more exponent rules. And what I've done is I've kind of put these out there. These are the same as what come out of your book. All right, and we're going to go over them, and then I'm going to discuss them, and I'm going to kind of discuss them in the backwards order that your book actually shows. So you're going to have to kind of follow along with that. Afterwards, we're going to give some examples of each and show you order of operations and how everything works there. So first, we talk about the zero exponent rule, and your book will say something to the zero power will always equal 1, and that is true. And it really doesn't matter what it is, whether it's a number, whether it's a letter. Anything raised to the zero power is always going to be 1. Your negative exponent rule says we acknowledge negative exponents happen. We really don't like them. It's kind of like a fraction that's not reduced. But into the negative 1, to get it to where it's not negative, we put it on the other side of the fractional bar. So it's kind of like the reciprocal, only it's not exactly. It reciprocates just that thing that is directly in front of it and below it. So in this case, n to the negative 1 is equal to, the n goes from the numerator to the denominator, making it positive, and you get 1 over n. And your quotient rule, which is, for all intents and purposes, when we're dividing bases that have exponents. And so you see n cubed over n squared, which your book would define as n to the 3 minus 2. And I like to simplify that guy just a little bit more if we can. So here's how we're going to do that. As we take a look at n cubed over n squared, we do understand, I'm going to back this up, we're going to write this in expanded form, that n cubed is actually n times n times n. N squared, on the other hand, is simply n times n. And then we go back to, we're all in multiplication division, so I can reduce this guy, and anything divided by itself, so n over n works out to be 1 over 1, or simply 1. Here again, we have n over n, which is 1 over 1, and we have n on top. And 1 times n is simply n. 1 times 1 is simply 1 in the denominator, but we don't need 1 in the denominator because anything divided by 1 is itself. Now, I do this one a little bit different. So I won't back this guy up as I just previously did. What I will take a look of is I will look at my bases. And what I have to remember is the product rule, which says when I multiply my bases, I add my exponents. Well, if we're not multiplying our bases, we're dividing our exponents. Division's the opposite of multiplication. Therefore, the opposite of adding my exponents would have to be subtracting my exponents. And what I like to do is I like to say, okay, yes, I do have an n cubed. I do have an n squared. Where do I have more n's, on top or bottom? Well, obviously, n cubed is more than n squared, so I have more n's on top. And then I say by how many? And when I say by how many, that's the same as saying the difference between 3 and 2 is 1. And I get to this answer just a little bit faster. So let's back up. Let's talk about the negative exponent rule, if we can. And what our negative exponent rule says, and if we take a look at that last problem we just did, we can make a negative exponent positive by taking it across the fractional bar. Well, the same is true if I think about it the other way. So if I want this 2 and I want this guy to be all linear, meaning on a straight line or horizontal, I can take it and put it up there, which makes it n cubed times n, and now it changes the positive negative, which makes it a negative 2. And now I'm back to the product rule where it says I'm multiplying the same base, I add my exponents. Well, when I add my exponents, I get the same answer as what I did previous problem. N to the 3 plus a negative 2 will still give me n to the 1, or simply just n. Let's back up one more time. Now this rule is just a little bit different than the previous two. What it's saying here is that I have maybe n cubed. I'm going to take n cubed. Well, if I take my negative exponent rule, I can take this guy, move it to the top, and I get n to the 3 times n to the negative 3, which does get me n to the 0. But if I go back, and I mean back to my quotient rule, we can say anything divided by itself is 1. Either way, n to the 0 power is always 1, or anything raised to the 0 power is always 1, or something divided by itself will always be 1. So let's go ahead, let's bounce forward a little bit, and let's do a couple of examples. Another page here. And let's take a look and see how these things actually react. So let's take an a squared b to the 4th, a squared b to the 4th, and let's just say c to the 5th. And I've got a to the 6th, b to the 3rd. B to the 3rd. Well, here again, I am dividing, which means I can reduce. So I take a look at this, and I'm going to go through my quotient rule on this one. So I have A's. Where do I have more A's? Well, I have them on the bottom. By how many? Well, the difference between 6 and 2 is 4. So I have 4 more A's on bottom. I have B's. Where do I have more B's at? I have more B's on top. And the difference between 4 and 3 is 1. And if I don't put that exponent, it is a 1. And then I look at my C's, and I have more C's. Well, I only have C's on the top. By how many is 5? And I know I'm a little off-centered, but that's okay. We can clean that up if we want to in another step or so. All right, but I'm fairly satisfied with you giving me that answer. So there's the quotient rule, very simple. Let's take a look at another one. Let's go X, Y, and Z. Let's go X, let's make it -1. Z, let's make it -2. We come over on the bottom side of things, we go X, Y, and let's put a Z in there. Let's go the -3 on Y, let's go -4 on Z. So now you can see, and you know, I used to have problems with this too. I don't like negatives. Well, if I want to find the difference between -1 and 1, sometimes it's a little bit more problematic, and you kind of have to think of number lines sometimes. But really that difference is 2, because one's on one side of the number line, by 1 away from 0, and the other one's on the other side, a unit or absolute value distance of 1. Well, I don't like to do that. I like to use my negative exponent rule. And my negative exponent rule, let me switch markers here, basically says that guy needs to drop down. This guy needs to go up. This guy down, and that guy up. Well, let's simplify this out just a little bit so you kind of understand what I'm looking at. So my x to the -1 went down. So I have that x, which was already down there, and now I have that -1 that comes down, making it +1. So I have another x down there. My y that was in the top sits there. My y to the -3 also comes to the top and makes it y cubed. Now my z to the -2 and z to the -4, they both switch, which means down here on the bottom, when my z to the -2 comes across that fractional bar, it becomes positive. And my z to the -4th, when it comes up across that fractional bar, it becomes positive. And now I'm right back in my negative exponent rule. So I have x's on the bottom. And x times x is add my exponents, I get 2. My y's are on top. And because they're both on top, I'm multiplying them, same basis, just like my x values. I have a 1 plus 3, which is 4. Y's on top. My z's now, I have some on top and bottom, which means now I'm going to find the difference between those. And I've got more on top by 2. And that is my answer on that particular guy. Let's go ahead and work another one. Let's say I have m to the 7th n. Let's take that to the -2 power, that quantity. Then let's make a fraction in there, because I know you guys all love our fractions. And n cubed. Well, now you can do this a couple different ways, all right? My way that I want to do it, I don't like my negative exponents, so I'm going to take my negative exponents and make those positive, which is fairly simple to do. So I'm going to take my m to the fourth, and it comes to the top. That's positive 4. My quantity of m to the seventh n to the negative 2 goes to the bottom, thus making it positive 2. And I'm still left in the bottom with that n cubed. It never changed because it was positive to begin with. We're going to leave it as such. Now, when I'm dealing with fractions, I got to simplify the top or simplify the bottom before I can simplify across. So that parenthesis in the bottom has to come worked out. So nothing I can do inside of it, so my exponent of 2 behind it has to be incorporated into it. So yes, I still have m to the fourth on top, but now I have on the bottom, I have an m to the 14th, I have an n squared, and I have another n to the cube that was sitting there beforehand. And now it's very similar to the previous problem where I have more m's on bottom by 10, and I have n's on bottom, but I add my exponents there because of the product rule, and I get n to the fifth. Well, what happens up here to the top? Well, it's no different than what we did previous. Let's back up and let's see that guy. Let me find it here. Here, it's no different than right here. Anything divided by itself is 1, which leaves me, if this n would have fallen on the bottom, it would have left me with just 1 times 1, which would have been 1 on the top. So if we apply that back to my problem here, I have m to the fourth on top. It would have reduced direct with an m to the fourth on the bottom, which would have made it 1 on top and bottom, and then left me with m to the 10th on the bottom. So my numerator in this case is 1. And remember, I cannot leave that guy off like I could if it fell in the denominator. So be very, very careful of that guy right there. We'll star that. Make sure you understand that guy right there. And let's do one more problem before we call it a day. Let's make negative exponents as an exponential to our quantity. So let's go p to the negative fourth q all over r to the negative third. Let's make that quantity to the negative third. All right. Here again, our order of operations never fail us. Is there anything I can do to simplify that problem inside the parentheses? Well, yeah, I can get rid of my negative exponents. When I do, I get r cubed up top. My p to the negative 4 comes to the bottom, thus making it p to the positive 4. And my q still stays on top where it was. Here again, everything's still to the negative 3 power. Now there's nothing else I can do inside my parentheses, so therefore I take a look at that exponent on the outside, and the negative exponent on the outside flips it, right? So my numerator becomes my denominator, or vice versa. Well, when I have a fraction like this, it flips the whole fraction to make it positive. So what was once on the bottom now becomes on top. So that p to the 4 comes on top. That r cubed, which is on top, now becomes on the bottom, following along with that q. So it just flips that or reciprocates that entire fraction. And now I've got, quite simply, p to the fourth raised to the third power. If you remember our other product rules or our other rules of exponents, I get on top p to the 12th. I have r cubed to the cube, which now makes it r to the 9th. And I have q to the, remember that guy's a 1, to the third is actually q to the third. Hope this helps you out in this section.